Good afternoon. I'm Andy Chamberlain. This is my partner Ryan Hobson, and we are both mechanical engineers, and we designed the fence post and small brush puller. Our problem was to design and fabricate a fence post and small brush pulling implement to mount on a skid steer or equipment with a quick attach plate. This is a quick attach plate, and as you can clearly see, it's marked green because the bright green project was actually Ethan and Matt's from earlier. It shows the hitch on the tractor hooking into the plate on the bucket, and that is just how a quick attach tractor works. Some specifications which we had to meet when designing our product was the amount of use. We made the assumption that it was for the average homeowner and it would get used about once or twice per week during the summer months, but for all day, so we built it fairly rugged. The size of the jaw had a 7-inch minimum opening. Hydraulic pressure available was about 2,500 psi. We did not need to save the removed items that we pulled up, which included the fence post or brush. We just considered them trash. Ease of manufacture and reliability were both things we also needed to consider. Machines which it needed to be compatible with are listed above. All of these machines could supply between 2,200 and 2,800 psi at the auxiliary hydraulic pressure. With these designs, with that specification, we were able to come up with 3 main ideas. One is a toothed arm design, fixed with very rugged teeth with a moving arm to bite into the fence post. Next, we had a chain pulling or strap type design, which you would use with logs, the same type of that, or finger type jaws, which would work quite well when grabbing the round objects and would also be less abrasive to the materials pulling. And here I introduce Ryan, who will talk about the design.
This was a matrix that we used, just like all of the other groups, to decide our design. As you can see, the tooth jaw design, which is what we ended up doing, scored a 21, and that's what we decided to do. This here is an isometric view, or basically just an all-around view of our final project. Even though it was a very basic design, there was still a lot of work that had to be done in SolidWorks. Most of the work went into finding a good place for the hydraulic cylinder mounts, which you'll see there and there. And basically the position of those dictated how far the jaw could open. We needed to maintain our 7 inches, but also if we moved the jaw or the mount over, it would also affect the grip that we would get, so our 3,000 pounds specified. The top picture clearly shows the jaws and the teeth, which would move, and the bottom picture clearly shows the supports on the fixed arm, so that was not intended to move under any circumstances. Top shows our back, or that would be for the quick attach. So that would be compatible with the plates that were specified earlier. And the front would also show that vertical support for that fixed arm. A lot of analysis did go into the stress analysis. A lot was done with it. And basically, what you see there, that hole is our main pivot point. So that takes the responsibility of the moving arm for taking the load, and also it needs to pivot on that. So basically, we started with this design. and a hole drilled straight through the square tubing. What we found and what we decided to test was that if we introduced a bushing, this would be the bushing that we had. Basically, a bushing is just like a sleeve of thick steel, and it would disperse the force out instead of focusing on very small shear points on the bolt. And when we introduced that, we found that the stress in this arm would be reduced by 23%. Not only would it reduce the stress, making the arm stronger, making it be able to bear more weight, but it would also increase longevity on our bolt. The same was done with the hydraulic mounts. The left shows the original design, and if you can see that there, the mount is to be welded directly to the frame. And then what we found was, or what we thought of, that would see a lot of stress, and it did, and that would ultimately deform. So what we did, that plate is a 3/8 stock. We put that in between the steel box frame and the mount, and what that did, it actually increased the strength of those mounts by 81%. We did that on both mounts, and it proved that it would not deform under extreme circumstances. We did do a few preliminary tests, and one of them was to see just how much force it would take to actually bite into a cedar fence post. We used a 4-inch cedar fence post and mocked up these replica teeth. We used a Tinius-Olson testing machine, and basically all that does is exert a compressive force. And what we found was about 3,000 pounds would be sufficient. So that was the design that we basically started with, that helped us select our cylinder, and also the geometry of our mounts, as I was talking about earlier. This table shows the results from that grip testing, and basically what that shows, at 3,000 pounds, the teeth, the top tooth dug in 0.63 inches, and it also shows that it exerted about 1,300 psi. And also, this last column shows if you were to lift it up vertically, it would be able to withstand 970 pounds before it would shear. This was also just some hand analysis that we used, and basically what this calculation did, it gave us the ratio at which the cylinder exerts the force onto the actual arm. Because it's at an angle, the cylinder does not exert it directly, so we found that there's a ratio of about 0.66. And what that would mean is if you had, say, a 9,000 pound cylinder, about 6,500 pounds would be transmitted to actual crushing force. So that was important. I'm going to pass it off to Andy, and he's going to cover the construction.
So during the construction phase of our project, being pretty much all metalwork, it included a lot of welding, shown by Ryan here, a lot of grinding, which I did a lot of, and we also included a lot of plasma cutting. Here shows the fixed arm of our project in place, fairly self-explanatory. And here shows the moving arm and its joint. This bolt holding that joint together for the arm is 1.25" grade 8 bolt. The shear strength of this bolt is 105,000 psi. With an area of 1.226 inches squared, the shear force on that would be 257,000 pounds. With 2 shear planes, that would be 129 tons. We figured out the equivalent of this if you could support the bolt in a manner where it would have a direct shearing force. You could hold up 51 Honda Civics before that bolt would snap, or 37 Toyota Camrys. So that bolt is definitely overkill in the amount of strength in which is there. However, we wanted a large bolt, so there was a lot of surface area on the bushing because it was also a pivoting joint. This image here just shows the back side of our project and the mounting which we had to weld on to make to a quick attach plate, or basically make our own quick attach plate. You can see the pocket on the top as well as holes on the bottom for the pins to latch into. We did some testing on our project. This just shows it set up on the John Deere skid steer down at the TC farm. It looks and worked quite well. Here we were testing that same cedar fence post which we tested previously and preliminarily with over 6,000 pounds of force at the jaw. It definitely bit in a substantial amount, and unfortunately we were unable to pull a fence post out of the ground. However, with a bite like that, there is no doubt that it would be able to do it. Our project was also to pull out small brush, and so we did that too, and this successfully pulled out a cluster of buckthorn, root ball included. It is a very invasive plant and very difficult to get up, and we successfully pulled this up. And being how it can pull up a root ball, it reassured the fact that it would most likely be able to pull up a fence post. Here's Ryan back to talk about some changes.
After our testing, that first testing that you just saw the picture of, we did find a problem or two. The first problem was that the strength of the bushing joint, which I'll cover, and also the plate that because we needed to fabricate our own, it didn't fit quite right onto the quick attach. So what we did to solve the problem with the plate, I'm not sure if you can see it, but there's an extra strip of 1/4-inch steel there, just welded, and that made it fit tighter onto the attachment. The other problem was, on our original design, that bushing that we were talking about earlier was only attached by 1 bead of weld, and on the top, 1 bead of weld. Because you can knock it on the inside of the weld, there was not a lot of contact for the weld. Basically what happened is that bushing came loose. What we did to solve the problem was weld that bushing in solid to all 4 sides of the tube. So there's a lot more weld, a lot more strength. This just shows the hours that we had into our project. We looked at about 165. This would just show cost of materials, all said and done, it was around $780. Factoring in cost for labor, at about $12 an hour for labor, at 57 hours, and also factoring the manufacturing, which would be like the lathe and the mill, we're looking at a total around $821. The final product cost to factor in labor would be around $1,600. Comparable products on the market today would be around $1,800. We thought that we did a very good job, and we were very proud of our product. A few things that we would maybe do differently, probably would be maybe accommodate a wider opening for the jaw, and also we got a little overzealous with welding. So basically, like that bottom mount probably could have been addressed if we just kept it tacked, tested it on the machine, and then we can adjust it easily. But we were just going by measurements. We would like to thank Jim Ross for helping us with welding, Michael Wright for always being there in the shop and helping us with everything we needed, and John Kidder for helping us with the post analysis testing. Are there any questions? Yes.
The fixed arm has that 45-degree support. Why didn't the rotating arm also get one?
The rotating arm did get one. It was on that top plate. Let's see if I can go back. It's not mounted directly onto the arm. If you notice here, there's two plates, which this square tubing is sandwiched together. These are the gussets for that, to hold that up. So that acted as the same way.